Right now, the fastest object our species has ever built is falling through the dark beyond the planets, moving at about 17 kilometers every second. Its name is Voyager 1, and it is never coming home. But here is the part almost no one knows. Voyager will never leave the galaxy either. It is far too slow. Instead of escaping, it will circle the center of the Milky Way, around and around, for billions of years, going nowhere, held forever by a pull it can never break. Our fastest emissary is a prisoner, and it does not even know it. Look up on a clear dark night, and in the direction of the constellation Andromeda, you can find a faint smudge of light. That smudge is an entire galaxy, 1 trillion stars, and the light touching your eye tonight left it 2.5 million years ago. You can see it. You could never ever reach it. Which leaves a question worth sitting with tonight. Is there any way out of here at all? Tonight, we are going to find out whether we could ever escape the Milky Way, and what it would take even to try. By the end of this, you will understand exactly how large our galaxy is and how far we would have to travel to leave it, what we would have to survive on the way, and why the galaxy's own gravity makes it so hard to break free. And you will understand the strangest part of all, which is that even if we somehow got out, almost every other galaxy in the universe is already slipping permanently beyond our reach. If a question this big is your idea of a good night, a subscribe keeps the next one coming. Now, start with the size of the thing we are trying to leave, because until you feel that, none of the rest makes sense. The Milky Way is a flattened disk of stars, and it is about 100,000 light-years across. Let that number sit for a second. A light-year is the distance light travels in a year, moving at 186,000 miles every second, and the galaxy is 100,000 of them wide. It holds a few hundred billion stars, our sun among them, all turning together in a slow wheel that takes hundreds of millions of years to complete a single rotation. This is not a place, it is closer to an ocean made of stars, and we are one drop somewhere inside it. And where we are inside it matters enormously for any thought of leaving. We are not at the center, and we are not at the edge. The sun sits about 26,000 light-years out from the core, roughly halfway to the rim, tucked into one of the spiral arms, a structure called the Orion Arm. So we are stranded in the middle of the disk, with tens of thousands of light-years of stars in every direction along the plane. If your plan to escape was to fly toward the nearest edge across the disk, you would be aiming at something more than 20,000 light-years away, through the crowded heart of the galaxy's starfields. That is not the way out, and understanding why not is the first real step. Because the galaxy is a disk, and a disk is thin, 100,000 light-years wide, yes, but only about 1,000 light-years thick. It is shaped less like a ball and more like a colossal plate, or 2 dinner plates set rim to rim, wide and flat, which means the shortest way out of the bright galaxy is not across it at all. It is straight up, perpendicular to the plane, punching out through the thin dimension, out the top or the bottom of the disk, rather than across its enormous width. Go up, and you only have to cross a few hundred to 1,000 light-years of stars before you break out of the bright disk into the darker space above it. Go sideways, and you have 100,000 light-years to fight through. So already the geometry has told us something. There is a shortest way out, and it points up, out of the plane. But do not mistake shortest for short. 1,000 light-years, the thin way out, is still an almost meaningless distance by any human measure. The nearest star to the sun is a little over 4 light-years away, and we will see in a moment just how long even that would take to reach. 1,000 light-years is that gap multiplied more than 200 times over. The thin dimension of the galaxy, the easy direction, the escape hatch, is still hundreds of times farther than the nearest star we cannot yet reach. That is the scale we are dealing with. Even the short way out is longer than anything we have language for. I want to be honest about one thing right at the start, because it complicates even this. The galaxy has no sharp edge. The disk does not stop at a clean line. It thins out and fades, and beyond the bright stars there is a faint scattered halo of older stars, and beyond that something larger and stranger still that we will come to later, reaching much farther out than the light does. So even the question of where the Milky Way ends does not have one clean answer. The bright part has a rough size. The whole thing, gravitationally, is far larger, and that gap between where the galaxy looks like it ends and where it actually ends is going to matter more than almost anything else tonight. It helps to shrink the galaxy down to something the mind can actually hold. So try this. Imagine the whole Milky Way scaled down until it was the size of a continent, say the width of North America. On that scale, the distance between our Sun and the very nearest star would be only a few hundred meters, close enough to walk in a few minutes. And on that same scale, the entire solar system, the Sun and all its planets out to the farthest ice, would be smaller than a coin lying on the ground. That is the emptiness we live in. Stars like grains, spread across a continent, each one a tiny coin, and between them nothing but dark. Now remember that this continent-sized galaxy is 100,000 light-years wide in reality, and that we sit 26,000 light-years from its center, and you start to feel the true problem. We are not near an edge we could run for. We are deep inside an ocean of these coins, with the nearest shore tens of thousands of light-years away in every direction along the plane. There is one more feature of our position worth naming, because it will matter later. We move. The Sun is not sitting still in the galaxy. It is sweeping around the galactic center at about 230 kilometers every second, dragging the whole solar system with it, completing one enormous orbit, roughly every 230 million years. The last time the Sun was on this exact side of the galaxy, the ancestors of the dinosaurs were only beginning to rise. So we are not stationary residents of the Milky Way. We are already in motion around it, bound to it, circling its center at a speed that sounds enormous and is still nowhere near enough to leave. We are, in a sense, already doing what Voyager will do forever, going around and never out. There is a reason we cannot simply look and see the whole shape of our own galaxy, and it deepens the strangeness of trying to leave it. We are inside it. We have never seen the Milky Way from outside, and we never will, because no camera we own is anywhere near far enough out to turn around and photograph it whole. Every picture you have ever seen of the Milky Way as a grand spiral seen from above is either another galaxy standing in for ours, or an artist's reconstruction pieced together from measurements taken from our seat inside the disk. We map our own galaxy the way someone lost in a forest maps the forest, by carefully surveying what is near and inferring the rest, never able to rise above the trees and look down. So even our picture of the place we are trying to escape is assembled from the inside, a map drawn by prisoners who have never seen the outside of their own walls. There is something fitting in that. We are trying to find the exit from a structure we cannot even fully see, because we have never once been far enough away to look back at it whole. And the motion around the galaxy hides a further trap that is worth naming now. Because the Sun is sweeping around the galactic center at over 200 kilometers per second, any ship we launch inherits that motion, carried along sideways with the whole solar system whether we like it or not. To leave the galaxy, you would have to deal with that inherited speed, either using it or fighting it, but either way you begin your escape already moving fast, in a direction that keeps you in orbit rather than carrying you out. Our starting condition is not rest. It is a high-speed orbit around the very thing we are trying to leave. And that orbit is not a head start toward the exit, but a commitment to circling. Everything born in the galaxy is born already going around it, already bound, already turning. To break out is not to start moving. It is to change a motion we have had since before we existed, a motion the whole solar system has carried for billions of years, and to change it by adding a speed far larger than the one we already have. There is one more thing about our address that reframes the whole question of leaving, and it is easy to miss. We think of the galaxy as our home and the space beyond as the destination, but from a purely physical view, we are not residents who might step outside. We are made of the galaxy, built from its material, bound into its motion, held in its gravity from the moment we formed. The atoms in your body were forged in the galaxy's stars and gathered by its gravity into the cloud that became the sun and the earth and you. To leave the galaxy is not like walking out of a house you happen to live in. It is like a wave trying to leave the ocean, or a current trying to step out of the river that is carrying it. We are not simply inside the Milky Way, we are of it, part of its slow turning, and the idea of getting out is stranger and harder than the idea of merely travelling far, because it means separating ourselves from the very system that made us and still moves us. That does not make it impossible in principle, but it is worth feeling how deep the belonging goes, because the gravity that holds us is only the outermost sign of it. It is worth holding one number in mind as a kind of anchor for everything that follows, because it puts our whole situation in a single frame. The nearest star to the Sun is about 4 light-years away, and even that, the closest neighbour we have, is a distance no human being or human machine has ever come remotely close to crossing. Now take that distance, the 4 light-years we cannot cross, and remember that the galaxy is 100,000 light-years wide, 25,000 times larger, and that the nearest large galaxy is 2.5 million light-years away, more than 500,000 times the already impossible gap. Every scale in this video is built out of that one unreachable unit, the distance to the nearest star, stacked up thousands and millions of times over. So when the numbers start to blur, come back to this: we cannot yet cross to even one neighbouring star, and leaving the galaxy would mean crossing the equivalent of that gap tens of thousands of times in a row. The problem is not that the galaxy is a little too big, it is that the galaxy is built out of distances we already cannot manage, repeated more times than we can hold in the mind. So that is where we stand, a drop in an ocean of a few 100 billion stars, 26,000 light-years from the centre, with the nearest way out being a climb of 1,000 light-years straight up out of a thin bright disk into a dark that has no clear edge. On a clear night we can look up and see out of it all the way to that Andromeda smudge, another whole galaxy across the dark. The strange thing, the thing this whole video is about, is that seeing out and getting out turn out to be nothing alike, which raises the obvious next question. If that is the distance, how fast can the fastest thing we have ever built actually go? The fastest object our species has ever sent outward is Voyager 1, and it is leaving the Sun at about 17 kilometers every second. 17 kilometers in the time it takes to say the word. That is roughly 38,000 miles an hour, and by any human standard it is an enormous speed. It would cross the entire United States in about 7 minutes. It crossed the distance from the Earth to the Moon, which took the Apollo astronauts 3 days, in about 9 hours. Nothing we have ever built goes outward faster. And against the galaxy, it is a crawl so slow it is almost heartbreaking. Here is the arithmetic that shows why. At 17 kilometers per second, Voyager takes about 17,000 years to cross a single light year. 1 light year. 17,000 years, the nearest star to our Sun, Proxima Centauri, is a little over 4 light years away. So if Voyager were pointed straight at it, which it is not, it would take more than 70,000 years to arrive. 70,000 years to reach the closest star there is. More time than our entire species has existed as we now are, spent crossing to the single nearest neighbour, and the galaxy is 100,000 light-years across. The numbers stop meaning anything. Our fastest machine, going flat out, would need longer than the current age of the universe just to cross the galaxy once, and it will never even do that, for reasons we are about to get to. Now, someone always asks, is Voyager really the fastest? And strictly no, there is a faster machine, the Parker Solar Probe, which has reached nearly 200 kilometers per second, more than 10 times Voyager's speed. But there is a catch, and it matters, Parker reached that speed by falling inward, diving down toward the sun, deep into the sun's gravity, where everything moves faster. It is not heading out of the solar system, let alone out of the galaxy. Instead, it loops around the sun, bound to it, whipping through its closest approaches at tremendous speed, and then swinging back out, held on a leash of gravity it cannot break. For the actual job we are asking about tonight, leaving, heading outward, and never coming back, Voyager is still the benchmark, the fastest thing we have ever aimed at the dark and released, and Voyager, as we will see, is not going to make it. Think about what that means for the whole question. The distances are measured in tens of thousands and hundreds of thousands of light years. Our fastest emissary crosses 1 light year in 17,000 years. Put those two facts side by side and the scale of the problem becomes clear. This is not a matter of building a slightly better rocket or waiting a few more centuries for the technology to improve. The gap between how fast we can go and how fast we would need to go is not a gap you close with a better engine of the same kind. It is a chasm of a different order, and everything else tonight is really about just how deep that chasm goes. We can dream up faster ships on paper, of course, engines that burn nuclear fuel, sails pushed by starlight or by beams of light we fire ourselves, designs that might someday reach a real fraction of the speed of light. None of them exist. Not one has ever flown. The gap between what we have actually built and what real escape would demand is not small, and it is not a matter of tens of percent. The gap is a factor of tens, and in some ways far more than that, and we are going to see exactly where those walls stand. But first, there is a puzzle sitting right in front of us, hiding in that little probe falling through the dark. It is worth dwelling on how strange it feels that 17 kilometers per second, a speed no human machine has ever beaten going outward, is the slow part of this story. At that speed, you could cross an entire country between 2 breaths. You could circle the whole Earth in well under an hour. If you fired a rifle, the bullet would look frozen in the air beside Voyager, because the probe is moving something like 20 times faster than the bullet. By every standard that has ever mattered to human beings, 17 kilometers per second is blindingly, impossibly fast, and it buys us almost nothing here. That is the vertigo of galactic distance. It takes the fastest thing we have ever made, a speed that would have seemed like magic to anyone in history, and renders it a cruel, because the gap it has to cross is measured in units where even light, hundreds of thousands of times faster than Voyager, takes tens of thousands of years. And there is a quiet detail about Voyager that makes its situation even starker. It is not slowing down in any way that will ever stop it, and it is not speeding up either. Out beyond the planets, with nothing to push against and nothing to burn, it simply coasts, carrying whatever speed it had when the last gravity of the outer planets released it. 17 kilometers per second is not a stage in its acceleration. It is very nearly the final word, the speed it will carry, more or less, for as long as it exists. There is no reserve, no next gear, no plan to go faster. What Voyager has now is what Voyager will always have, and what it has is 30 times too little. The fastest thing we ever built long ago finished getting faster, and it finished far, far short of the speed that leaving would take. People sometimes ask why we cannot just build something far faster, and the honest answer is that speed in space is not about engines the way it is on a road. Out here there is nothing to push against, so a ship carries its own reaction mass and throws it out the back to move forward, and to go faster it must throw mass out harder or carry far more of it. To reach even a tenth of the speed of light by any method we understand, a ship would need either an almost unimaginable amount of fuel, far more than the ship itself, or an entirely new way of moving that we have not built. Sails driven by fleets of powerful lasers, or engines that harness reactions we can barely sustain in a laboratory for a fraction of a second. None of it exists as a working machine. All of it lives in design studies and equations. So when I say Voyager is the benchmark, I do not mean we lack only the will to do better. I mean that going meaningfully faster is not an engineering tweak away. It is a problem we have not actually solved, only sketched. The gap between 17 kilometers per second and the speed's escape would demand is not a gap of ambition. It is a gap of physics we have not yet mastered, and may never. It is worth being clear about what the speed of light actually does to this whole discussion, because it is the ceiling above every ceiling. Everything I have said about Voyager being too slow might make you think the answer is simply a faster ship, and up to a point that is right. But there is a hard limit to how fast anything can go, and it is the speed of light which nothing carrying mass can reach, let alone exceed. So the very best any ship could ever do, the absolute physical maximum, is to approach that speed, and we saw what even that buys: 100,000 years to cross the galaxy, millions to reach another. This matters because it means the distance problem does not have an engineering solution waiting at the end of enough progress. There is a wall built into the universe, the light speed limit, and even pressed right up against that wall the galaxy stays enormous, and the other galaxies stay millions of years away. We are not merely slower than we would like to be, we are slower than the universe's own hard limit, and even that limit is not fast enough to make the galaxy small. The fastest anything can ever go still cannot make leaving quick. That is a different kind of no than not having a good enough engine. It is the universe itself setting the pace, and the pace is not enough. I find it worth sitting with the fact that Voyager, right now as you listen to this, is still out there doing exactly what we have been describing. It is not a thought experiment or a figure from history. This is a real machine, launched decades ago, still moving at its 17 kilometers per second, already the most distant object human hands have ever made, and still only a tiny fraction of the way even to the nearest star. Its power is slowly fading, and within years it will fall silent, its instruments going dark one by one until it stops speaking to us at all. But it will not stop moving, long after it goes quiet. Long after everyone who built it is gone, long after our own civilization has changed beyond recognition, Voyager will still be out there, coasting, carrying its little golden record and its frozen speed, looping around the galaxy on the orbit it is already locked into. It will outlast us, almost certainly. And in all that time, across all those ages, it will never once leave the galaxy, because it was never going fast enough to, and there is nothing out there to speed it up. Our farthest reach into the dark is a machine that will circle home forever, without ever getting out. There is no better emblem for the whole of tonight than that. So Voyager, the fastest thing we have ever launched, is not escaping the galaxy. It is going to loop around the center of the Milky Way, over and over, essentially forever. And that is not because it ran out of fuel, and not because we aimed it wrong. There is a reason the galaxy will not let go of it, a reason that stands in the way of anything we might ever try to send out, and it is not the reason most people would guess. I will come back to it, and when I do, it changes what escaping even means. Hold on to it. So which way do you actually go, and how far is it really? We already found the clue in the shape of the galaxy. The disk is 100,000 light years wide, but only about 1,000 thick, so you do not aim across it. You aim up, straight out of the plane, perpendicular to the disk, punching through the thin dimension into the dark above or below. That is the shortest possible route out of the bright galaxy, and it means crossing a few hundred to about 1,000 light years of stars, rather than the tens of thousands you would face heading for the rim. The geometry hands you the fast way out for free. It just does not make the fast way out anything close to fast. Put Voyager on that shortest path and do the arithmetic. 1,000 light years, at 17 kilometers per second, at 17,000 years for every single light year, comes out to something on the order of 17 million years, just to rise out of the visible disk. 17 million years, the whole of human history, everything we have ever done, from the first stone tools to now, fits into the last few 100,000 years, and this is that stretch of time run through more than 50 times over, spent simply climbing out of the bright layer of our own galaxy. And that is the easy direction. Aim across the disk instead, toward the far rim, and at Voyager's pace you are looking at something on the order of 1 billion years of travel, a length of time in which the sun itself will have changed, and the continents of the Earth will be unrecognizable, all of it spent crossing the galaxy just once. Now do the same trip at the one speed nothing can exceed, the speed of light itself. Even light, the absolute limit of the universe, the thing that crosses from the sun to the Earth in 8 minutes, takes real time here. To rise the 1,000 light years out of the disk, light needs 1,000 years. To cross the full width of the galaxy, light needs 100,000 years. So even if we could somehow build a ship that touched the speed of light, which the laws of physics may forbid outright, the crossing of our own galaxy would still take 100,000 years, longer than our species has existed. There is no speed that makes the Milky Way small. The galaxy is simply larger than speed can fix. This is the thing I keep coming back to about distance on this scale. We are used to distance being something you defeat with speed. Somewhere far becomes near if you go fast enough. The galaxy breaks that rule. The distances are so enormous that even the universe's own speed limit, light, cannot cross them in anything less than the lifespan of a species, and our fastest real machine cannot cross them in anything less than the lifespan of a world. Speed, the thing we always reach for, barely helps. The gap is too big for it. There is a way to feel the difference between going up and going across that makes the geometry vivid. The disk of the galaxy, at 100,000 light years wide and 1,000 thick, has the proportions of a stack of paper or a vinyl record, something far wider than it is deep. If the whole galaxy was shrunk to the width of a dinner plate, it would be about as thick as a coin laid on that plate. So the fast way out is obvious once you see the shape. You do not swim the length of the plate. You step off its face, straight up, through the thin dimension. For us, sitting inside the disk, that means the darkness of intergalactic space is closer above our heads and below our feet, perpendicular to the band of the Milky Way we see across the sky, than it is in the direction of that band itself. The bright river of stars we call the Milky Way is us looking along the wide way, through the crowded plain. The empty dark above and below is the short way out. But even choosing the short way, the numbers stay merciless, and it is worth being precise about why. The problem is not really the direction. It is that a light year is so enormous that even the thin dimension of the galaxy contains hundreds of them, and each one at Voyager's pace is 17,000 years of travel. So the geometry saves you a factor of 100, turning 100,000 light years into roughly 1,000, and a factor of 100 sounds like it should change everything. It changes almost nothing, because 100th of an impossible number is still an impossible number. 17 million years instead of 1 billion. Both are longer than our species has existed. Both are far beyond any machine or crew we could send. When the underlying distances are this large, even the clever shortcut only trades one unreachable answer for another. It is worth being honest that even these numbers are optimistic, because they assume you could somehow already be moving at full speed the whole way, and that is not how anything real works. A real ship has to accelerate up to speed and then slow down again at the far end, and both take time and enormous energy. For a crewed vessel there is a further limit, the human body itself, which can only take a gentle push for long before it becomes unbearable, so you cannot simply slam up to speed in a hurry. Reaching a large fraction of light speed at any comfortable rate of acceleration would itself take years, and shedding it again at the destination would take years more, all of it added on top of the crossing. So every figure I have given you, the 17 million years, the billion years, the 100,000 years at light speed, is a flaw, the very best case, assuming instant speed and ignoring the slowing down at the end. The real trips would be longer, the distances are already beyond reach, and everything real about how a ship actually moves only makes them worse. I keep coming back to one comparison that makes the hopelessness of the distance concrete, and it involves the whole span of life on Earth rather than just human history. Complex life has existed on our world for something like 500 million years. In all that time, at Voyager's speed, a probe launched at the dawn of the first animals would by now have crossed only a fraction of the way across the galaxy, nowhere near the far side, still deep within the disk. The entire history of animal life, unfolding for hundreds of millions of years, is not enough time for our fastest machine to cross our own galaxy even once. That is the measure of it. Not a human lifetime, not a civilization, not even the whole span of recorded history, but the entire age of complex life, and still the crossing is unfinished. When a distance is so large that all the time animals have existed does not suffice to cross it at our best speed, you are no longer talking about a hard trip. You are talking about a barrier that time itself, on any scale we can live inside, cannot defeat. The galaxy is not far the way a destination is far. It is far the way the past is far, beyond returning to. There is a subtler point buried in all these timescales that is worth drawing out, because it changes what escape would even mean for a crew. Any trip out of the galaxy, even the shortest way, takes far longer than a human life, which means no single crew could ever make it. The people who launched would die in transit, and their children, and their children's children, generation after generation born and dying inside a moving ship, for tens of thousands of generations at the very least, before anyone arrived anywhere. So leaving the galaxy is not a voyage in the ordinary sense at all. It is the launch of a tiny travelling world that would have to keep humans alive, fed, sane, and reproducing across a span of time longer than all of recorded history, sealed inside a single vessel crossing the dark. Nothing we know how to build could do that. We have never kept anything running or any group of people alive and whole for even a fraction of such a span. So even setting the physics of speed and radiation aside, the sheer duration defeats us in a separate way, demanding not a fast ship, but an enclosed civilization that could endure for ages between the stars. The distance does not just outrun our engines, it outruns our lifetimes, our societies, and very likely our species as it now exists. And there is a reason none of the usual hopeful answers rescue us here, which is worth saying directly so it does not hang unanswered. People reach, understandably, for the ideas science fiction has given us: faster than light travel, wormholes, folding space, some shortcut that sidesteps the distance entirely. I would love to tell you one of them works, but every one of those ideas is either flatly forbidden by the physics we actually understand, or rests on conditions so far beyond anything we can create that they are indistinguishable from fantasy, exotic forms of matter we have never found, energies larger than whole stars could provide, held in configurations nothing in nature has ever shown us. They are not on the table as real options. They are stories we tell because the true distances are unbearable, and stories are easier to hold than 100,000 light years. I am not going to lean on them, because leaning on them would be lying to you about where we actually stand. Within the physics we can test and trust. The distance is real, the speed limit is real, and there is no shortcut waiting to be found. The honest picture has no secret door in it, and pretending otherwise would betray the whole point of looking squarely at what is true. And here is the part one want you to hold, because the next sections turn on it. Rising out of the bright disk is not the same as escaping the galaxy. Say you did it. Say you spent your 17 million years and climbed up out of the stars, and now the disk of the Milky Way lies below you, a wheel of light seen from above, and around you is dark. You would feel like you had left. You would be wrong. You would be clear of the stars, out of the bright part, and still be held, completely, by the galaxy's gravity, still bound to fall back, still a prisoner of a pull that reaches far beyond anything you can see. Clearing the stars is not clearing the galaxy, which brings us to the crossing itself, because before you even get that far, the empty space you are flying through turns out not to be empty and not to be safe. The space between the stars is not empty, and the faster you try to cross it, the more deadly it becomes. This is the trap hiding inside the whole idea of going fast. To beat these distances in any reasonable time, you have to move at a real fraction of the speed of light, and the moment you do, the thin nothing you are flying through turns into a wall. Start with what is actually out there. Interstellar space, the gap between one star and the next, holds a thin haze of gas, mostly hydrogen, at a density of very roughly 1 atom in every cubic centimetre. 1 atom in a space the size of a sugar cube. That is emptier than the best vacuum we can make in any laboratory on Earth. So empty that at slow speeds it is nothing at all. A perfect void for all practical purposes. Scattered through that gas are tiny grains of dust, specks of carbon and silicate and ice, again spread so thinly that you could cross enormous distances without ever meeting one. At Voyager's crawl, none of this matters in the slightest. The problem only appears when you go fast. Because when you fly into those atoms at a large fraction of the speed of light, they stop being a gentle haze and become radiation. Each hydrogen atom you slam into at that speed hits your ship like a particle in an accelerator, and the steady stream of them becomes a beam of hard radiation pouring onto the front of the craft, blasting the leading face of anything crossing that fast. Above about 1/10 of the speed of light, the oncoming flow would be fierce enough to kill an unshielded human crew, cooking them through the hull. Push faster still, and it would degrade even hardened electronics in minutes, frying the machine itself. The very hydrogen that is too thin to notice at slow speed becomes, at high speed, a river of radiation aimed straight at your face. The distance demands that you go fast, and going fast turns the emptiness into the thing that kills you. And the dust is worse. A single grain of interstellar dust, a speck far smaller than a sand grain, struck at a large fraction of light speed, carries the energy of a small explosion. At those speeds, a fleck of matter you could not even see becomes a bomb. And interstellar space, thin as it is not perfectly clean. We do not even fully know how much larger debris is scattered out there between the stars, which means we do not fully know how dangerous the crossing would really be. It might be survivable with enormous shielding. It might be worse than we think. What is certain is that the gentle vacuum of the slow traveller becomes, for the fast one, a field strewn with tiny bombs. There is one small mercy close to home, and it is worth knowing because it shows the danger is real enough that where you start actually matters. Our own corner of the galaxy sits inside a bubble. Long ago, one or more stars near us exploded as supernovae, and the blast swept the gas out of a region around the Sun, leaving a cavity called the local bubble, a rough sphere a few hundred light years across where the gas is about 100 times thinner than the galactic average. We are inside that cleared out blast cavity right now, in an unusually empty pocket of an already empty galaxy. But the bubble has walls. Cross a few hundred light years in any direction, and you reach the denser gas beyond, where the haze thickens back up and the crossing gets harder. Even our head start is small, a slightly emptier room inside a house we still cannot leave. The reason speed turns the gentle gas into a weapon is worth understanding, because it is the same physics that lets us build particle accelerators, only turned against the traveller. When you sit still in interstellar space, a hydrogen atom drifting past carries almost no energy. It is cold, slow, harmless. But energy of motion depends on speed, and it climbs steeply as you approach the speed of light. Fly into that same atom at half the speed of light, and from the ship's point of view, it is no longer a drifting speck. It is a proton slamming in at enormous energy, exactly the kind of particle we accelerate in giant machines to probe the heart of matter, except that here it is the ship that is moving, and the whole thin cloud of them is streaming into the hull. A crossing at relativistic speed would be like living inside the beam of a particle accelerator aimed permanently at your face. The gas does not change. Your speed changes what the gas is, turning a harmless haze into hard radiation simply by how fast you meet it. And this sets a cruel ceiling on how fast it is safe to go, which collides head-on with how fast you need to go. To cross the galaxy in anything less than 100,000 years, you need a real fraction of light speed. To survive the interstellar gas, you need to stay slow enough that the oncoming atoms do not cook you, which means staying well below the speeds that would make the trip quick. Those two demands point in opposite directions, and there is no obvious place they meet. Go fast enough to arrive in a reasonable time and the radiation kills you. Go slow enough to survive the radiation and the trip takes longer than a civilization is likely to last. Shielding might push that ceiling up somewhat. Thick walls of matter to soak up the oncoming particles, but shielding is mass, and mass is the very thing that makes going fast harder in the first place. Every solution feeds the next problem. The faster you try to beat the distance, the harder the universe pushes back. The local bubble we sit inside is worth one more look, because it is a reminder that the galaxy is not a static place but a violent one, constantly reshaped by dying stars. That cavity around us, a few hundred light years of unusually thin gas, was carved by supernovae, the explosions of massive stars ending their lives, blasting shells of force outward that swept the surrounding gas away and left a bubble behind. We drifted into this cleared out region, or it formed around us, within the last few million years, and it is why the space immediately around the Sun is calmer and emptier than the galactic average. But bubbles like this are temporary features in a churning galaxy. The walls of denser gas around us are still there, and beyond them lie clouds far thicker than anything near us, some of them dense enough and cold enough to be collapsing into new stars. A ship heading out of the galaxy would not stay in our calm pocket for long. It would cross the wall of the bubble and enter the rougher gas beyond, where the hazard of the crossing climbs. Our quiet neighborhood is the exception, not the rule, a brief lull carved by ancient explosions, and leaving means leaving its shelter almost at once. There is a grim symmetry worth noticing in the problem of the crossing, because it mirrors the trap of the distance itself. The distance punishes you two ways: too slow and it takes forever, too fast and the gas kills you, with no comfortable speed in between. The same shape shows up everywhere in this question. Every apparent solution creates the next problem. Want to go faster to beat the distance, and the radiation rises to meet you. Want to shield against the radiation, and the shielding is mass that makes going fast harder. Want to carry more fuel to reach higher speed, and the fuel is weight that demands still more fuel to move. At every turn, the universe answers each fix with a fresh obstacle, as though the difficulty were conserved, impossible to remove, only to shuffle from one form to another. This is not bad luck or poor engineering. It is the deep structure of the problem. The reason leaving the galaxy is not a challenge waiting for a breakthrough, but a knot that tightens the harder you pull. And we have not even reached the part where the galaxy's own gravity refuses to let go, which is worse than all of it. It helps to picture what the crossing would actually feel like, from inside a ship moving fast enough to matter, because the danger is not dramatic in the way people expect. There would be no asteroid field to dodge, no visible hazard rushing at the windows. The gas is invisible, individual atoms far too small to see, and yet the front of the ship would be glowing under a constant silent bombardment, its leading surface heating and degrading, radiation streaming through into whatever lay behind it. The crew would not see the thing killing them. They would simply be receiving a steadily lethal dose from the empty-looking space ahead, the accumulated hammering of countless atoms too small to notice one at a time. That is the strange, quiet horror of the interstellar crossing at speed. Not a storm, but a clear, empty path that is nonetheless soaking the ship in radiation the whole way. An emptiness that looks like nothing and behaves like a furnace aimed at the bow. The threat is invisible, constant and inescapable, while the speed is held, and the speed cannot be given up without surrendering the crossing to time. Even the danger out here is made of nothing and is deadly all the same. So put it together. To have any hope of crossing these distances in a workable time, you must go fast. Going fast turns the thin gas into lethal radiation and the specks of dust into explosions. Slow down to survive the crossing, and the crossing takes millions of years. It is a trap with the jaws set both ways, punishing you for speed and punishing you for slowness, and it stands between us and even the nearest edge of the galaxy. And yet, suppose you solved even this. Suppose you built a ship that could survive the crossing and cleared the disk at last, and rose up out of the stars into the dark above. Would you finally be free of the galaxy then? Here is where the real trap closes, and where we find out why Voyager will never leave. Here is the answer to the puzzle I asked you to hold, and it is the reason Voyager will never leave. Clearing the visible galaxy, rising up out of the stars, is not the same as escaping it. Not even close, because the galaxy's gravity reaches far, far beyond the part of it you can see, and to truly break that grip, you would need to be moving at a speed that dwarfs anything we can reach. This is the wall, and it is worth understanding exactly, because it is the single hardest fact in the whole question of escape. To break free of the Milky Way's gravity, to climb out of its pull and never fall back, an object out here at our distance from the center would have to be moving at around 550 kilometers every second. 550. Now remember Voyager, our fastest machine, the benchmark, the best we have ever done. Voyager moves at 17, not 550, 17. It is short of galactic escape speed by a factor of more than 30. Our fastest emissary is not almost fast enough, not off by a little, not a generation of engineering away. It is moving at barely 3% of the speed it would need to leave, which is why it is not leaving at all. Voyager will rise and slow and turn and fall back, again and again, looping around the galactic center for billions of years, one more bound object wheeling in the crowd, exactly like the stars around it. It will wander the galaxy forever. It will never once get out. And now the part that makes this so much deeper than it first looks. You might think the galaxy's gravity comes from the stars, from all those hundreds of billions of suns, and that once you climb above them, their pull would fade and you would coast free. It does not work that way, because most of the galaxy's mass is not the stars at all. It is something we cannot see. Surrounding the bright disk, reaching far above and below and beyond it, is an enormous halo of dark matter, a kind of mass that gives off no light and that we detect only by its gravity, and there is several times more of it than there is of all the stars combined. The bright galaxy, the beautiful spiral of light, is just the glowing core of something much larger and completely invisible, a great sphere of unseen mass that stretches out to distances that make the bright disk look small. So the edge you can see is not the edge you have to escape. This is the cruel heart of it. You could rise up out of the stars, look down at the whole shining wheel of the Milky Way spread out below you, and feel certain you had left it behind, and you would still be deep inside the well, held by a mass you cannot even see, being pulled back down by the invisible halo you are still buried in. The galaxy does not end where its light ends. It ends, gravitationally, much, much farther out, in that dark halo, and the whole enormous depth of that well is what anything trying to leave has to climb, not just the bright part, all of it. The visible galaxy is a false horizon. The true wall is invisible, and it is far bigger. That is why 550 kilometers per second is the price, and why we are so hopelessly far from paying it. I want to be fair about the uncertainty, because the exact number is still being worked out. Measurements of the escape speed at our position range, from roughly 500 to 600 kilometers per second, depending on how much dark matter there is, and how it is spread, and the precise size and shape of the halo, are genuinely open questions. But notice that the uncertainty does not help us at all. Whether the true figure is 500 or 600, it is tens of times beyond Voyager either way. The debate is about the exact height of a wall we cannot get within 30-fold of climbing. The wall is there no matter how you measure it. It is worth pausing on what dark matter actually is, because it is the invisible thing that seals us in, and it is genuinely one of the strangest facts in all of science. When we measure how fast stars orbit the center of the galaxy, and how fast galaxies move within their groups, the numbers do not add up. There is far more gravity at work than the visible stars and gas could ever produce. Something unseen is holding it all together, something that gives off no light, absorbs no light, and interacts with ordinary matter through gravity alone. We call it dark matter, and there is roughly 5 or 6 times as much of it by mass as there is of everything we can see. The stars, the gas, the dust, all the glowing material of the Milky Way are a minority, a bright sediment suspended in a much larger cloud of invisible mass. We do not know what it is. We have never caught a particle of it directly, but we can map its gravity. And its gravity is most of what holds the galaxy together and most of what holds us in. That is what makes the trap so complete. The wall we would have to climb is not even made of anything we can see or touch or point to. It is a mountain of invisible mass, wrapped around and through the galaxy, extending far beyond the last visible star, and its only signature is the pull it exerts, the pull that sets escape speed at 550 kilometers per second and keeps Voyager looping forever. You could fly out past every star in the Milky Way, look back and see the whole bright spiral shining behind you, and still be sinking through an unseen ocean of this stuff, still being drawn back by a mass you cannot detect with any eye or instrument aboard your ship except by the way it refuses to let you go. The bars of the cage are invisible. That is perhaps the most unsettling part of all. We are held by something we cannot even see, and it makes up most of the galaxy we are trying to leave. There is a way to feel just how deep this invisible well really is, and it comes back to speed once more. The sun is not standing still against the galaxy. It is already sweeping around the galactic center at more than 200 kilometers per second, held in that orbit by the galaxy's gravity, dark matter and all. 200 kilometers per second is more than 10 times Voyager's speed, and even that enormous velocity is not escape velocity. It is merely the speed of a stable orbit, the speed of staying, not leaving. To actually break free, you would need to add hundreds of kilometers per second on top of the orbital motion the sun already has. Think about that. Our entire solar system is already tearing around the galaxy at a speed that dwarfs anything we could build, and it is still not nearly enough to leave. It is exactly the speed required to stay bound, circling forever. The galaxy does not hold us gently. It holds us at 200 kilometers per second and asks for far more before it will even consider letting go. And we cannot add even a fraction of what it asks. We are riding a carousel spinning faster than any machine we own, and the carousel is barely half as fast as the speed that would fling us clear. There is a question people reasonably ask at this point, which is whether we could use the galaxy's own motions to help fling us out, the way we use a planet's gravity to speed up a probe. And the honest answer is that it would not be nearly enough. We do slingshot spacecraft past planets to gain speed, stealing a little of the planet's motion, and it works, adding a few kilometers per second here and there. But the gap we need to close is not a few kilometers per second. It is more than 500, on top of everything we already have. Even swinging past the most massive objects in the galaxy, even threading close by the giant black hole at the galactic center, the boosts available fall hopelessly short of what escape demands, and the maneuvers to reach those objects would themselves take ages and carry their own lethal dangers. There is no clever gravitational trick that adds up to escape, because the well is simply too deep and the speed required too high. The tools that let us cross the solar system, the gravity assists and the careful timing, are useful for moving between planets bound to the same sun. They do almost nothing against the far deeper problem of leaving the galaxy that binds all those suns together. The scale has changed, and the old tricks do not scale with it. I want to make the scale of the dark matter halo as vivid as I can, because it is the thing most people have never pictured. The bright disk of the Milky Way, the part with all the stars, is about 100,000 light years across. The dark matter halo surrounding it is thought to reach out perhaps 1 million light years or more in every direction, a rough sphere many times wider than the visible galaxy, mostly empty of stars but full of that invisible mass. So the galaxy you see, the beautiful spiral, sits at the center of an unseen sphere so much larger that the bright part is like a bright yolk in the middle of an enormous dark egg. And that whole sphere, the full width of the halo, is what an escaping object is climbing out of, held by the mass spread through all of it. When we say Voyager will orbit forever, this is the region it orbits within, looping through a well that extends far past the last visible star into that dark and enormous halo. The galaxy we can see is the small, bright, central part of something much larger that we cannot see at all, and the larger dark thing is the true shape of the trap. We do not even live in the whole galaxy. We live in its glowing core, wrapped in an invisible mass many times our size, and the invisible part is most of what holds us. There is a final way to feel the completeness of the trap, and it is to notice that every direction is the same. When we talk about escaping a planet, there is an up, a clear direction away from the surface, and once you are moving fast enough that way, you are gone. The galaxy offers no such clean exit. Because the dark matter halo surrounds it as a rough sphere, the pull reaches inward from every side, and no matter which way you flew, up out of the disk or across it or at any angle between, you would be climbing the same deep well, held by the same invisible mass wrapped around you on all sides. There is no soft spot in the wall, no direction where the gravity conveniently thins out and lets you slip through. The trap is spherical, closed in every direction at once, and the only way out of it, any way out of it, is the same brutal 550 kilometers per second we cannot come close to reaching. So it is not that we have failed to find the right direction to escape. Every direction is walled the same. The galaxy holds us not along one axis, but through a whole surrounding shell of unseen mass, and there is no gap in it anywhere to aim for. So here is where we stand at the middle of all this, and it is worth sitting with because it is the vertiginous center of the whole question. The galaxy is not a place with an exit you simply have to reach. It is a gravitational pit, far deeper and far wider than the glowing part we can see, lined with invisible mass, and our fastest machine is a permanent prisoner at the bottom of it, circling forever, 30 times too slow to ever climb out. That is the true shape of the trap, and yet let us grant the impossible for a moment, because the rest of the story is out there waiting. Suppose you did break free, suppose you climbed the whole invisible well and rose out into the space between the galaxies. What is actually waiting for you out there in the dark? Suppose you did it. Suppose you broke the grip and rose out of the galaxy entirely, up out of the dark halo and into the true void beyond. The first thing you would learn is that the emptiness between galaxies makes everything inside the galaxy look crowded. The space between the stars was thin, one atom to a sugar cube. The space between the galaxies is emptier still, a near-perfect nothing stretching across distances so large that the whole 100,000 light-year galaxy behind you shrinks to a single smudge, like the one we see when we look at Andromeda. You have not reached anywhere. You have only risen into a deeper, wider dark than the one you left. And when you look around for somewhere to go, the nearest things are not the great galaxies you might expect. They are small, faint, ragged clouds of stars that hang close to the Milky Way, its own little companions. The nearest of the notable ones is the large Magellanic Cloud, a dwarf galaxy visible to the naked eye from the southern half of the Earth as a dim detached patch of the Milky Way, and it lies about 160,000 light-years away. Farther out, around 200,000 light-years, is its smaller sibling, the Small Magellanic Cloud. These are the closest galactic neighbours we have, and already they sit farther from us than the entire width of the Milky Way itself. The nearest galaxies to our own are farther away than one side of our galaxy is from the other. That is the gulf you have risen into. But here is the thing about those little clouds. They are not free, independent galaxies you could think of as separate destinations. They are captives. The Magellanic Clouds are bound to the Milky Way, held by its gravity, orbiting it the way moons orbit a planet, slowly being pulled and stretched by the giant they circle. And they are not the only ones. Our galaxy is surrounded by dozens of these small satellite galaxies, faint dwarfs caught in its pull, and some of them are being actively destroyed. One of them, the Sagittarius dwarf, is right now being torn apart and swallowed, its stars pulled out into long streams that wrap around the Milky Way like ribbons, the shredded remains of a galaxy being eaten alive. The nearest galaxies to us are not places you would escape to. They are prisoners in the same well we are, being dragged in and dismantled. So the first lesson of the gap is a hard one. Rising out of the Milky Way does not deliver you to a neighborhood of nearby worlds to visit. It delivers you to a near-perfect emptiness in which the closest things are our own galaxy's doomed captives, spread across distances larger than the galaxy you just escaped. The void is not a road between close destinations. It is a barrier far wider than anything inside the galaxy, and the things floating nearest in it are being reeled back in even as you look at them. The fate of the Sagittarius dwarf is worth looking at closely because it shows what the space around a galaxy really does to the small things that come near it. This little galaxy wandered too close to the Milky Way, and our galaxy's gravity is pulling it apart, stretching its stars into enormous curving streams that now loop right around our galaxy, over the top and under the bottom, wrapping it like ribbons of stolen stars. The dwarf is not being politely absorbed. It is being unraveled, its stars stripped away a few at a time, and scattered into the halo of the Milky Way, its structure dissolving over hundreds of millions of years. This is the ordinary fate of a small galaxy that ventures near a large one. It does not visit. It is caught, torn and eaten, its stars added to the larger galaxy's own. The Milky Way has done this many times before, growing in part by devouring smaller galaxies that strayed too close, and the streams of their dismembered stars still hang in its halo as evidence. So the space just outside our galaxy is not a peaceful shore dotted with quiet neighbours. It is a killing ground for anything small enough to be caught. The satellite galaxies that orbit the Milky Way are not stable, permanent companions. They are prey in slow motion, being reeled in and taken apart. And this tells you something about the emptiness beyond, too. The reason real, independent galaxies are so far away, millions of light years off, is partly that anything closer has already been captured or destroyed by the giants. Galaxies keep their distance because the ones that did not keep their distance are gone, absorbed into larger ones long ago. The gulf between free galaxies is not just empty space, it is the safe distance, the range beyond which a galaxy can stay itself instead of becoming someone else's stars. And even that safe distance, as we are about to see, is no protection against the thing that is carrying them all away. It is worth stepping back to see the pattern in all of this, because it repeats at every scale. Small galaxies are captured and torn apart by large ones, their stars absorbed. Large galaxies in bound groups drift together and merge into single larger ones. Everywhere gravity can reach, it pulls things together, collects them, consolidates them, so that over time the number of separate objects goes down and the survivors grow larger by eating the rest. The Milky Way itself is a product of this, built up over billions of years by swallowing smaller galaxies, and it is still doing it now, with the Sagittarius dwarf and others. So the neighborhood around any large galaxy is not a stable set of companions, but a slow feeding, the big growing at the expense of the small. This matters for our question because it means the space near us is not somewhere you could island hop across a chain of close galaxies. The close ones are being consumed, and the ones far enough away to survive are millions of light years off. Gravity has cleared the neighborhood, leaving only the giant and its doomed captives with a wide empty moat before the next free galaxy. The emptiness between galaxies is not just distance, it is the mark of everything closer having already been pulled in and eaten. It is worth pausing on just how empty the space between galaxies really is, because it is hard to hold in the mind. Inside the galaxy, thin as it is, there is at least the occasional star, the occasional cloud of gas, something every few light years. In the true intergalactic void, the gaps are millions of light years wide, with almost nothing in them at all, a near total emptiness where a lone atom might be the only thing for enormous stretches in every direction. If you were somehow set adrift out there, halfway between the Milky Way and Andromeda, you would see galaxies as distant patches of light scattered around you, but nothing near, nothing to reach, nothing to stand on, only the dark and the far-off islands of stars, each one over 1,000,000 light-years away. It is the emptiest kind of place the universe contains, and it is most of the universe by volume. The galaxies, for all their size, are rare bright specks in an ocean of nothing, and the ocean is what you would actually have to cross to get from one to another. When people picture space travel, they picture the specks. The reality of leaving a galaxy is the ocean, and the ocean is almost all there is. It is worth naming what the Magellanic Clouds actually look like, for anyone who has never stood under a truly dark southern sky, because it makes the gulf personal. From the southern hemisphere, far from city light, the two clouds hang overhead as soft, detached patches of glow, like torn pieces of the Milky Way drifting on their own. For most of human history, no one knew what they were, only that they were there, faint and permanent, wheeling with the stars. Now we know each one is an entire galaxy, hundreds of millions or billions of stars, the nearest sizable galaxies to our own. And even these, our closest galactic neighbours, are more than 100,000 light-years away, being slowly torn apart by our galaxy's pull. You can stand on the Earth and see them with your own eyes, two whole galaxies glowing quietly overhead. And they are already farther than any ship could cross, already caught and dying in the grip of the Milky Way. The nearest galaxies we have are close enough to see plainly and far enough to be forever out of reach and doomed on top of it. That is the pattern of this entire universe in one glance at the southern sky, visible, unreachable, and not even permanent. There is a reason the void between galaxies is worth dwelling on rather than rushing past, because it is the true answer to where you would go after escaping. And the answer is almost nowhere. Having climbed out of the galaxy at impossible cost, a traveller would find themselves not at a destination, but in the middle of the widest emptiness there is. With the Milky Way shrinking behind, and the nearest independent galaxy still over 2,000,000 light-years ahead, the escape does not deliver you anywhere. It delivers you into the gap, and the gap is the largest and emptiest part of the whole problem. A crossing that dwarfs the one you just made to leave the galaxy. Getting out of the Milky Way, as impossibly hard as it is, would only be the first and smallest step, opening onto a void so wide that the galaxy you struggled to leave was, by comparison, a crowded and cozy place. This is what people miss when they imagine escaping the galaxy as the goal. Leaving is not arriving. Beyond the galaxy is not a new shore, but an ocean far larger than the island. And the next island is millions of light years across it. And that next island, unless it is one of our bound few, is receding as you go. The escape, even achieved, would strand you in the emptiest place of all. I find something clarifying in that in a bleak way. We tend to picture the galaxies as scattered close together, a short hop apart, because in photographs they crowd the frame. The truth is the opposite. Galaxies are rare islands separated by enormous empty gulfs, and the few that huddle near our own are held there by gravity, not by chance, our own small flock kept close and slowly consumed. To find a galaxy that is genuinely separate, genuinely its own place, and large enough to matter, you have to look much farther out. You have to look, in fact, at the smudge we started with, which raises the question that decides everything. Of all the galaxies out there, which ones could we ever actually reach? The nearest large galaxy to our own is Andromeda, and it is the faint smudge from the start of this video. It lies about 2.5 million light-years away, a great spiral wheel of perhaps 1 trillion stars, larger than the Milky Way itself, turning slowly in the dark. That patch of light you can find on a clear night in the direction of the constellation Andromeda is not a star and not a cloud of gas in our own galaxy. It is an entire other galaxy, 1 trillion suns, so far away that the light reaching your eye tonight left it 2.5 million years ago, when our own ancestors were barely recognizable. You are seeing Andromeda not as it is, but as it was before there were people to look. and it is the closest large galaxy there is. Beyond Andromeda lies one more sizable spiral, Triangulum, a smaller galaxy about 2.7 million light-years out, fainter and looser than Andromeda, but still a real galaxy of many billions of stars. And around and between these three, the Milky Way, Andromeda and Triangulum, are scattered dozens of smaller galaxies, the dwarfs and satellites, all of them bound together by gravity into a single loose collection. This collection has a name. It is called the Local Group, and it is about 10 million light-years across, and it holds somewhere around 80 galaxies in all, bound to one another, moving together through the larger dark. This is our neighborhood, in the truest sense, and here is the hard part, the part that turns this whole section from a travel brochure into something colder. The Local Group is, in the end, the entire list of places we could ever reach. All of it. Every galaxy we could, even in principle, in some unimaginable far future, ever hope to travel to, is in this one small bound collection, and there is essentially nothing beyond it that we could ever get to. The reason is the thing the next section is about, but the short version is this. The galaxies of the Local Group are gravitationally bound to us and to each other, held together, not being carried away, and that binding is the only thing that keeps them within reach. Andromeda is even coming toward us, falling closer at about 110 kilometers per second, drawn in by the same gravity that binds the group. These galaxies stay. They are held. Everything outside this group is a different story entirely, and it is the story that closes the door. I want to be honest about what reachable even means here, because I am not telling you we could actually go to Andromeda. We could not remotely, not with anything we can imagine building. Remember the arithmetic. At Voyager's speed, crossing a single light year takes 17,000 years, and Andromeda is 2.5 million light years away. The trip would take longer than the current age of the universe, many times over. When I say the Local Group is the only reachable part of the universe, I do not mean we have a way to reach it. I mean something more subtle and more final. I mean these are the only galaxies that are not being actively carried beyond any possible reach by the expansion of the universe itself. Everything in the Local Group is, at least in principle, still on our side of a line. Everything beyond it has already crossed to the far side of that line forever. There is something worth saying about how we even know Andromeda is a separate galaxy, because for most of human history no one did. For thousands of years that faint smudge was just another blur in the sky, assumed to be a cloud of gas within our own Milky Way. One more patch among many. The idea that it might be a separate island of stars, a whole other galaxy as large as our own, was not confirmed until we measured its distance and found it lay far outside anything that could belong to the Milky Way. In that moment, the known universe grew almost beyond comprehension, from a single galaxy to a universe of them, and Andromeda was the first proof that our galaxy was not the whole of creation, but one island among countless others. That faint smudge is where humanity first learnt it lived in one galaxy among many, and it remains the nearest of those many that is large and separate and real. I keep returning to a strange tension in that. Andromeda is at once the most reachable large galaxy there is, and completely unreachable in any practical sense. It is the closest, the one we would aim for first, the only giant galaxy near enough to be bound to us, rather than fleeing, and it is still 2.5 million light-years away, a distance that turns even the dream of crossing it into something no real ship could ever attempt, a trip longer than the age of the universe at any speed we can reach. So it sits in a peculiar category all its own, near enough to be, in the deepest sense, still on our side of the cosmic doors, still part of the bound island that will not be carried away, far enough that reaching it is a fantasy. It is the nearest thing to a neighbouring shore that we have, and the shore is 2.5 million light-years off, across a sea we cannot cross. That, more than any number, is what the scale of the universe feels like once you sit with it. There is a detail about the Local Group worth making concrete, because it changes how you picture our situation. When you look at a photograph crowded with galaxies, hundreds of them scattered across the frame. It is natural to assume we live among that crowd, that galaxies are all around us close at hand. We do not. Almost every galaxy in those deep images lies far outside the local group, millions or billions of light years beyond it, already on the far side of the expanding gulf. Our actual neighborhood, the galaxies genuinely near us and bound to us, is a short list, dominated by just two large spirals, ourselves and Andromeda, with Triangulum a distant third, and everything else a scattering of dwarfs. Two real cities and a lot of villages, adrift in a sea, with the next real city so far off their light is millions of years stale by the time it arrives. That is the true shape of our cosmic address. Not a crowded metropolis of galaxies, but a small bound cluster of a few dozen, most of them faint, floating alone in an emptiness that only grows. The crowded sky in the photographs is a sky of the already lost. I think the hardest thing to hold about Andromeda is that it is genuinely the good news of this video, and it is still crushing. Of everything we have looked at tonight, Andromeda is the hopeful part, the one large galaxy near enough to be bound to us, the one that is not fleeing, the one that will still be there in our sky as everything else recedes. It is, in the language of this whole question, reachable on the right side of the doors. And reaching it is still a fantasy so far beyond us that stating the travel time becomes almost absurd, longer than the universe has so far existed, at any speed we could ever build. So this is what the best case looks like. The most reachable galaxy in existence, the nearest neighbor, the one piece of good news, is a place we could see every clear night of our lives and never come within a millionth of the way toward. When the good news is that unreachable, you begin to feel the true weight of the bad. Andromeda is the door left open, and even the open door is 2.5 million light years away, across a void no ship could cross. That is as close to an exit as this universe offers us, and it is no exit at all. There is a final thing about the local group worth stating plainly, because it is the quiet flaw under all the grander facts. This small bound cluster of galaxies is not just the list of places we could reach, it is the list of places that will still exist, for us, in the deep future. As the expansion carries everything else beyond the horizon, the local group is what remains, the whole of the accessible universe narrowing down to these few dozen galaxies, and then in time to the single merged galaxy they will become. So when I say the local group is all we could ever reach, I am also saying it is all that will ever, in any lasting sense, be there. The rest is leaving, and one day will be gone from the sky entirely. There is a strange intimacy in that. Once the grief of it settles, the universe, for all its unimaginable size, is quietly handing us a much smaller inheritance, a single island of stars, ours by gravity, kept close while everything else departs. It is not the universe we dreamed of inheriting, but it is apparently the one that is actually ours, the only ground that will not slip away beneath the expanding dark. Everything else was only ever a view. It is worth being clear about one more thing, so that no false hope slips in through the word bound. Yes, Andromeda and the local group are bound to us, held against the expansion, still on our side of the doors, but bound does not mean easy, and it does not mean reachable in any way we could actually use. It means only this, that these galaxies are not being carried away faster than light, that a signal sent toward them could in principle arrive, that they remain part of the same gravitational island as us across the deep future. It is a statement about which galaxies are not permanently lost, not a statement that any of them are within our grasp. The distance to Andromeda is still such that no ship we could build would ever cross it, and the same is true of every other member of the group larger than our own doorstep. So when I call the local group reachable, hold the word lightly. It is reachable only in the narrowest technical sense, the sense of not being sealed off by expansion, and even the nearest of it is a journey no real traveller could ever complete. The doors to the local group are not locked the way the rest of the universe is locked, but the hallway to them is still millions of light years long, and that is its own kind of shut. So of all the galaxies in existence, trillions of them scattered across the observable universe, the ones we could ever even theoretically reach number a few dozen, all bound to us in this one small island. And the nearest and largest of them is the smudge we can already see with the naked eye, the light that left Andromeda 2.5 million years ago and is only now arriving. There is something almost unbearable in that when you sit with it. The nearest galaxy we could ever reach is one we can only ever see, and it may be very nearly the only one, because beyond this small bound island, something is happening to the rest of the universe that puts it permanently out of reach, and it is time to face exactly what that is. The deepest reason there is no way out has nothing to do with the galaxy at all. It is that the universe is expanding, and the expansion is speeding up, and it is carrying almost every other galaxy permanently beyond our reach. This is the wall behind all the other walls, and it is the one that truly closes the door. Here is what is happening, stated plainly. Space itself is growing. Not the galaxies moving through space, but the space between the galaxies stretching, expanding in every direction at once, so that distant galaxies drift farther from us with every passing year. And that expansion is not steady. It is accelerating, getting faster over time, driven by something we do not understand and have named dark energy, a kind of pressure built into empty space that pushes everything apart harder the more space there is. The result is that the farther a galaxy is from us, the faster it is receding, and beyond a certain distance, galaxies are moving away faster than light itself. Nothing travels through space faster than light, and these galaxies are not doing so. The space between us and them is simply growing so fast that the gap widens faster than any light could ever cross it. And now the consequence, which is genuinely one of the bleakest facts I know. Any galaxy currently more than about 18 billion light years away is already permanently beyond our reach. Not merely far, not merely hard to get to, gone. Even a beam of light we sent out today, moving at the ultimate speed, could never catch it, because the space in between is growing faster than the light can close it. We could aim our fastest possible signal at those galaxies right now, and it would never, ever arrive. Not in a billion years, not in a trillion, not ever. They are sealed off from us for all of time by the expansion of the universe. And it is most of them. Astronomers estimate that around 94% of all the galaxies we can currently see are already past that line, already beyond any possible reach, forever. 94%. Nearly every galaxy your eye or any telescope has ever caught is a place we could never travel to, even if we could move at the speed of light and had forever to do it. We can still see their light, of course, the old light that left them long ago and is still arriving, but that light is a message from a place already gone, and we can never follow it back. The photons reach us. Nothing we send could ever reach them. The universe lets the light in and lets nothing out. And it is getting worse quietly all the time. Every year, more galaxies cross that line. As the expansion carries them past the threshold where their recession outruns light, they slip from the reachable universe into the unreachable one after another, and they never come back. The reachable universe is not fixed, it is shrinking. The number of places we could ever go is dropping, galaxy by galaxy, year by year, and the only things not being carried away are the ones bound to us by gravity, our own local group, that one small island holding together against a tide that is sweeping everything else beyond the horizon for good. It is worth being clear about what receding faster than light really means, because it sounds like it breaks the most famous rule in physics, and it does not. Nothing can move through space faster than light. That rule holds, always. But the galaxies crossing beyond our reach are not moving through space quickly at all. In their own neighborhoods, they sit nearly still, just as we do here. What is happening is that the space between us and them is expanding. New distance appearing everywhere along the way, all of it adding up. Add enough expanding space between 2 points and the total gap can grow faster than light can cross it, even though nothing in either place is actually traveling fast. It is the road itself lengthening, not the traveller speeding up. And because the road can lengthen without limit, there is a distance beyond which no signal, no ship, no beam of light, however fast, can ever close the gap, because the gap is growing faster than anything can traverse it. That distance is the edge of the reachable universe, and almost everything lies beyond it. What makes this final, in a way the galaxy's gravity is not, is that there is no maneuver against it. The gravity of the Milky Way is at least a wall you could imagine climbing with enough speed. It is a fixed thing, and a fast enough ship could in principle beat it. The expansion is different, because it is not somewhere you could fly to and get past. It happens everywhere, in all the space between here and there, all at once. And the farther you travel, the more of it there is ahead of you, growing as you go. You cannot get around it, because there is no around. You cannot outrun it, because it is not a thing that can be outrun, only more and more space appearing faster than you can cross it. A galaxy that has passed beyond the reachable edge is not merely far away and getting farther. It is gone in a way that no speed, not even the speed of light, could ever undo. That is what makes 94% of the universe not distant but lost. It is worth letting the number 94% land fully, because it is easy to hear it and move on without feeling it. Think of everything astronomers have ever catalogued, every galaxy captured in every deep survey, the great fields where a single image holds thousands of them stretching back through time. 94 out of every 100 of those galaxies are not distant destinations we might someday struggle toward. They are already gone, sealed off forever, as unreachable as if they had never existed, and we simply happen to still see the old light they sent out long ago before the door closed. We are looking at a sky full of ghosts. The light is real, still arriving, still carrying the image of those galaxies as they were. But the galaxies themselves are beyond any reach, any signal, any influence, for the rest of time. Of everything we can see, only a sliver, the nearest few dozen galaxies bound to us, is still genuinely there in any sense that matters, still on our side of the widening dark. Almost the entire visible universe is already a memory, a picture of places we lost before we even knew they were there to lose. And the cruelty of it is that seeing them costs us nothing, while reaching them costs us everything. The light pours in freely, crossing the growing gulf because it left long ago, when the galaxies were closer and the doors still open. So we get the view without the access, the image without the place, a universe we can study in exquisite detail and never touch. Every galaxy in every photograph is a window we can look through and never step past. That is the exact shape of being sealed in. Not blindness, but the opposite. A perfect view of everything we can never have, light from 1,000 billion places, arriving faithfully at a world that can reach almost none of them. The universe is generous with its light and absolute with its distances. It shows us everything and lets us go nowhere. It is worth being precise about the difference between what we can see and what we can reach, because they are not the same edge, and the gap between them is where the heartbreak lives. The observable universe, everything whose light has had time to reach us since the beginning, stretches out to something like 46 billion light years in every direction, an enormous sphere full of galaxies. But the reachable universe, the part we could actually send something to, even a beam of light, even given all of future time, is far smaller, bounded at roughly 18 billion light years. Everything in the gap between those two numbers, the enormous shell of galaxies we can see, but that lie beyond the reachable edge, is visible and utterly unreachable at the same time. We can study those galaxies, photograph them, measure their light, learn their histories, and never, under any circumstances, affect them or reach them or be reached by them again. They are like faces glimpsed through a window that is also a wall, present to our eyes, absent to everything else. That shell, the seen but unreachable, is most of the observable universe, and it grows as more galaxies cross from the reachable side to the merely visible side, sliding from places we might have touched into places we can only watch. The window keeps widening. The wall behind it never moves. There is a temptation hearing all this to hope that a civilization could simply move fast enough, early enough to outrun the closing doors, and it is worth explaining plainly why even that fails. You might think that if you left now, immediately, at nearly the speed of light, you could reach some distant galaxy before the expansion carried it away. But the numbers do not allow it. For almost every galaxy we can see, the space between us and it is already growing faster than light could cross it, which means a beam of light leaving today never arrives, and nothing we could send travels faster than light. The chance to reach those galaxies did not just close recently. For most of them it closed long ago, in the deep past, before there was anyone here to try. The reachable ones, the few we might in principle still catch, are essentially only those already bound to us by gravity, the local group, which is not fleeing at all. So there is no launching early enough, no going fast enough, to beat the expansion to the far galaxies. The race was lost before it began, decided by the growth of space itself over billions of years. We did not miss the window by a little. For all but our nearest neighbours, the window was never open in the first place. I want to make sure one distinction is clear, because it is the hinge the whole video turns on. The galaxy's gravity and the universe's expansion are two completely different kinds of barrier, and they fail us in different ways. The galaxy's gravity is, at least in principle, a solvable problem. It is a fixed well of a known depth, and a fast enough ship, one moving at more than 550 kilometers per second, would climb out of it and be free. We cannot build that ship, but the wall itself has a top. The expansion is a barrier of a different and worse kind, because it has no top and no far side. It is not a fixed well you could climb with enough speed. It is a growing distance that outruns any speed, including light, and grows faster the farther you try to go. So the two no's are not the same no. The galaxy says you are too slow, and might, in some distant dream, be answered by going faster. The expansion says there is no speed that would ever be enough, and cannot be answered at all. That is why the expansion, not the galaxy, is the true and final wall, and why the deepest reason there is no way out lies not in the thing we are trying to leave, but in the whole universe beyond it, pulling away. I have to be honest about the one uncertainty here, because it is a real one. All of this rests on dark energy behaving the way we think it does, staying constant, pushing steadily forever. That is our best current understanding, supported by strong evidence. But dark energy is a thing we genuinely do not understand, and there are a few recent hints that it might not be perfectly constant, that it might change over time in ways that could alter this far future picture. If it did, the story could look different. I do not want to overstate our certainty about something we cannot yet explain, but I also do not want to reach for false comfort, because the overwhelming weight of the evidence right now points one way. The doors are closing, most of them are already shut, and every year a few more swing closed. Which leaves one last hope worth checking. Is the small island we are left with at least safe and unchanging? Is home at least permanent? Even the small island we are left with will not stay the way it is. The local group is bound by gravity, which is the only reason it stays within reach at all. But that same binding means it is not stable and fixed. Over long enough spans of time, a bound group of galaxies does not simply hold its shape, it falls together. The galaxies drift inward, cross, tangle and merge, and the endpoint of a bound collection like ours is not a neighbourhood of separate galaxies, but a single one. Home, the one place we can never leave, is itself slowly collapsing inward. For a long time, the textbook version of this had a firm date. The Milky Way and Andromeda, the two giants of the local group, were said to be on a certain collision course, falling toward each other to merge in about 4.5 billion years into a single enormous galaxy, their two spirals scrambled together into one great elliptical ball of stars. Andromeda is indeed coming toward us, closing at about 110 kilometers per second, and for years that 4.5 billion year collision was treated as all but settled. But that certainty has recently cracked. New measurements have changed the picture, and this is a genuine live debate right now. When you fold in the gravity of the other big members of the group, in particular Triangulum pulling one way and the Large Magellanic Cloud pulling another, the future of the Milky Way and Andromeda becomes much less certain than it looked. The latest work, using the most precise positions and motions we have ever measured, now puts the odds of the two galaxies actually colliding in the next 10 billion years at only around 50%. A coin flip. The collision that was treated as destiny for years turns out, on better data, to be genuinely uncertain, as likely to be a near miss as a merger. This is one of those places where honest scientists are still arguing, where the answer is not yet settled, and I think that uncertainty is worth respecting rather than papering over. We do not know if the Milky Way and Andromeda will merge. Right now it is close to even odds. But here is what does not change, whichever way that coin lands. The long-term direction of a bound group is inward. Whether or not the Milky Way and Andromeda collide in the next 10 billion years, the local group as a whole, given enough time, is expected to fall together, its dozens of galaxies merging over spans of 100 billion years or more into a single giant galaxy alone. And by then, everything outside the group, all the other galaxies, the 94% and more, will have long since been carried beyond the horizon by the expansion, gone from the sky entirely. So the endpoint is a single merged galaxy, our own descendants of stars, sitting in a black and empty sky with nothing else visible in any direction, the rest of the universe having receded past the point of sight forever. It is worth sitting with how recently the certainty about Andromeda cracked, because it is a good reminder that even the pieces of this story we thought were settled can move. For years, the collision was told as a fact, complete with vivid descriptions of the two galaxies tearing through each other, the night sky filling with Andromeda's swelling spiral as it approached, a firm date of about 4.5 billion years attached to it all. It was in the textbooks and the documentaries as something known. Then better measurements arrived, more precise positions and motions for our galaxy and its neighbours, and when the pull of Triangulum and the Large Magellanic Cloud was properly folded in, the firm date dissolved into a coin flip. The earlier scientists were not careless. Measuring the sideways drift of a galaxy 2.5 million light-years away, precisely enough to predict a collision billions of years off, is simply at the very edge of what we can do. A tiny uncertainty in that sideways motion becomes the difference between a direct hit and a clean miss. So the honest state of it right now is that we do not know. The two galaxies might merge, they might sail past each other. It is close to even, but I want to be careful not to let that single uncertainty soften the larger picture, because the larger picture is not uncertain at all. Whether or not the Milky Way and Andromeda collide on schedule, the local group is bound, and bound groups fall together in the end, over timescales long enough to make even galactic orbits look quick. Hundreds of billions of years, the whole collection is expected to draw inward and merge into a single galaxy. That part rests on simple gravity, not on the delicate measurement of one sideways drift, and it is about as certain as anything in this whole story. The doors close on the wide universe first, as the expansion carries the far galaxies away, and then, much later, the small bright island that is left folds inward on itself and becomes one. The timing of the first step inside our group is genuinely debated. The direction is not. Everything, near and far, is on its way toward being either carried off or merged in, and the end of both roads is the same. One galaxy, alone, in the dark. There is something worth naming about what the far future actually looks like from inside that final merged galaxy, because it is the loneliest picture in all of astronomy. A civilization living in that single island of stars, 100 billion years or more from now, would look up into a sky with nothing in it but their own galaxy. No other galaxies visible anywhere, in any direction, at any magnification, because all of them would long since have receded beyond the horizon of the expanding universe, their light stretched and dimmed and finally lost entirely. Such a civilization, studying the sky as carefully as we do, would have no way of knowing that the universe had ever been full of galaxies at all. They would see one island of stars surrounded by perfect featureless dark, and they would reasonably conclude that this was the whole of creation, that their galaxy was the universe. Everything we can see tonight, the 94% and more, would be gone from their sky without a trace, the evidence carried away by the very expansion that stranded them. We are lucky, in a strange way, to be looking now while the light of the wider universe still reaches us. We happen to live early enough to see what later minds never could. The doors are closing, and we caught the sky while it was still full. There is a reason the merger of galaxies does not destroy their stars, and it circles back to the emptiness we keep meeting, which I find quietly astonishing every time. When two galaxies collide, you might expect countless stars to smash into one another, a firestorm of impacts. Almost none do. The stars within a galaxy are so far apart relative to their size that two galaxies can pass straight through each other and scarcely a single star will strike another. The galaxies merge, their shapes are torn and rebuilt, gas clouds collide and blaze with new star formation. But the individual stars mostly just slide past one another across the enormous gaps between them, rearranged into new orbits without ever touching. So when the local group finally falls together, it will not be a grinding of worlds but a slow gravitational reshuffling. Stars swept into new paths, the whole structure rebuilt into one, while each star sails on through the same enormous emptiness that always surrounded it. The emptiness that makes the galaxy impossible to cross is the same emptiness that lets galaxies merge without catastrophe. The distances that trap us also protect the stars from each other. It is the same fact, the enormous spacing of everything, wearing two different faces. It is worth drawing out one more implication of the far future picture, because it reaches back and touches us now. If a civilization living in that final, isolated galaxy could never know the wider universe existed, then the evidence we use to understand everything, the distant galaxies, the expansion, the whole grand history written in the light of far-off things, is evidence that is slowly disappearing. We are living in a rare window, cosmically speaking, when the universe is old enough to have formed galaxies and minds to study them, and still young enough that the light of the wider universe has not yet been carried away. Give it enough time and that window closes, and the deep truths become unknowable, erased not by any catastrophe, but simply by the quiet widening of space. So the same expansion that seals us in is also, slowly, hiding the explanation for why we are sealed in. We happen to be here in time to see both the walls and the reason for them, and that will not always be true for whoever comes after. There is something almost merciful in the timing of our existence, that we get to understand our own confinement before the proof of it slips over the horizon. Later minds may be trapped without ever knowing they are, in a sky that looks to them like the whole and only universe. That merged galaxy, alone in the dark, is the last shore. There is nowhere to go from there. No other galaxy left within reach, none even left within sight, just the one island of stars we were always bound to, now the whole of the visible universe. So the small refuge we were left with turns out not to be a refuge at all, only a slower version of the same story, everything falling together and going dark, the doors closing not just around the universe but around home itself. Which leaves us at last with the plain and honest answer to the question we started with. After all of it, the distance, the speed, the radiation, the invisible well, the expanding dark, the collapsing island, could we ever actually escape the Milky Way? So, could we ever escape the Milky Way? Here is the whole answer, laid out plainly. No new facts, just the verdicts the evidence points to. As we are, right now, the answer is no, and not close. Our fastest machine is more than 30 times too slow to break the galaxy's gravity, and it is doomed to circle the galactic center forever, never once getting out. The distances are such that even at the speed of light, which we cannot reach, crossing the galaxy would take 100,000 years, and the speed that might make the trip quick would turn the thin gas of space into a wall of radiation that kills the crew and wrecks the ship. That is the first no, and it is a firm one. For us, as we exist tonight, there is no way out. Then comes the deeper no, the one that would apply even to a civilization far beyond us. Suppose some species, someday, solved every one of those problems. Suppose they could leave their galaxy at will, cross the void, shrug off the radiation, ignore the distance. They would rise out into the universe only to find that almost all of it had already left. 94% of the galaxies are gone beyond reach, and more cross that line every year, carried off by an expansion that outruns light itself. The entire reachable universe, for anyone, is shrinking down toward a single bound group of galaxies, which is itself falling together into one island alone in the dark. There is no escaping that with any ship, any engine, any speed. You cannot outrun the expansion of space, because it is not a thing moving through space that you could chase down. The expansion is space itself growing everywhere at once, and there is no direction you could fly to get ahead of it. So the honest verdict has two layers, and both are hard. Escaping the Milky Way is not forbidden by physics the way some things are. There is no law that says a fast enough ship could not, in principle, climb out of the galaxy's gravity. It is forbidden instead by the sheer scale of the distances, by the depth of the invisible well we sit in, by the radiation that punishes speed, and above all by the expansion of everything, which is closing the doors faster than any ship could ever run for them. The thumbnail on this video says no way out. I built this expecting to push back on that, to find the loophole, the clever answer, the yes hiding under the no, and for once the honest science says the thumbnail is very nearly right. There is, in every way that matters to us, no way out. I do want to be fair and name the one crack of light, because I promise to be honest about uncertainty. All of this rests on two things staying true: that the laws of physics as we understand them cannot be broken, and that dark energy keeps behaving as it does now. Both are our best current understanding, backed by real evidence, but both are at the deepest level still open. We do not fully understand gravity at every scale. We do not understand dark energy at all, and a universe that surprised us on either could tell a different story. I am not promising you the walls are absolute. I am telling you that everything we actually know says they are, and that hoping otherwise means hoping our deepest physics is wrong. That is a thin hope and an honest one, and I will not dress it up as more than it is. I want to hold on to the honest uncertainty for a moment longer, because it is the only place any other answer could live, and it deserves a fair hearing. Everything bleak I have told you tonight rests on two pillars. The first is that the speed of light is a true and unbreakable limit, that no ship and no trick can ever exceed it or sidestep it. The second is that dark energy stays as it is, pushing space apart at an accelerating rate forever. If either pillar failed, the story would change. If there was some way around the speed of light that physics has simply not revealed to us, the distances might become crossable after all. If dark energy weakened or reversed, the doors might slow their closing or even open again. I cannot tell you those pillars are certain, because at the deepest level we do not fully understand either gravity or dark energy, and history is full of limits that turned out to have doors in them we had not yet found. But I also will not pretend the odds are better than they are, because that would be its own kind of lie. Everything we actually know, every measurement, every test, every piece of evidence we have gathered, says those two pillars hold. The speed of light has never once been beaten. Dark energy shows every sign of being steady and relentless. To hope for a way out is right now, to hope that our best and most tested physics is wrong in exactly the way we would need it to be, and that is a thin thread to hang a universe on. So I hold both things at once, and I think you should too. The walls are, as far as everything we know can tell, real and final, and the honest scientist always leaves the door open a crack, though the evidence does not point that way, because certainty about the deepest things is a trap of its own. What I will not do is tell you the crack is wider than it is. It is very narrow. The view from in here is very likely the only view we will ever have. When I set out to make this, I genuinely expected a different ending. I thought I would find the loophole, the clever route, the way that a sufficiently advanced civilization, if not us then someone, could slip the bonds of a single galaxy and spread outward into the universe. That is the story we are used to. The one where intelligence eventually goes everywhere, where the stars are a frontier waiting to be crossed. And the honest science kept refusing to give me that story. At every turn the walls were higher than I expected, the distances larger, the physics more final. The galaxy holds far tighter than I thought, through mass we cannot even see. The space between galaxies is wider and emptier than the pictures suggest, and the expansion is not a slow drift but an accelerating tide that has already carried most of the universe past any hope of reach. I came looking for the exit and found, instead, a very thorough account of why there is not one. That does not make the universe cruel, exactly, and I want to be careful how I put this. The universe is not built to trap us, it is simply built at a scale and on principles that leave us sealed in as a side effect, indifferent to whether we mind. The distances are not walls raised against us, they are just how big everything is. The expansion is not a door slammed in our faces, it is just what space does, everywhere, to everyone. There is no malice in any of it, and somehow that makes it heavier rather than lighter, because there is nothing to rage against, no barrier that might be broken by cleverness or will, only the plain size and behaviour of a universe that was never arranged with our leaving in mind. We are held by geometry and by physics, not by any hand. And geometry does not relent. There is a thought I cannot shake, now that I have followed all of this to its end. For as long as people have looked up, we have told ourselves that the sky was a frontier, that one day we would go out into it, spread among the stars, become a thing of many worlds. It is one of our oldest and most beautiful ideas about the future, and what the science actually says is gentler and far more sobering. The stars may be, in the very long run, a handful of the nearest ones, at enormous cost. The galaxy almost certainly not as we are, and perhaps not ever, and the other galaxies, the wider universe, almost none of it, ever, by anyone. The frontier we imagined turns out to have a fence around it, and the fence is not near the far edge of the universe but close, at the edge of our own galaxy, and beyond it a moat that is not only wide but widening. I do not say this to crush the dream, because I am not sure the dream was ever really about arriving. But I think honesty requires admitting that the universe is not the open road we imagined. It is more like a single lit room with a view of endless dark, and the view is genuinely beautiful and the door does not open. What we do with that, how we feel about a home we cannot leave, is the one thing tonight I am sure the science cannot decide for us. I said at the start that this was one of the bleaker things we have looked at, and I have not tried to soften it, because I do not think the truth is served by comfort it has not earned. But I want to end the reasoning, before the final reflection, on the one thing that is genuinely quietly astonishing in all of this, which is that we know it at all. We are creatures bound to a single small world, in a single galaxy, unable to leave even our own solar system, and yet from inside all of that we have measured the speed it would take to escape the galaxy, mapped the invisible mass that holds us, clocked the expansion of the entire universe, and worked out which galaxies are already lost, and which few remain. We cannot go anywhere, and we have understood everywhere. That is a strange and real kind of freedom, even inside the cage. We may never leave the Milky Way, but we have looked out from it far enough to see the whole shape of our confinement, to know its walls by name and number, and there is something in that refusal to look away that I find worth more than false hope. We are sealed in, and we know exactly how, and we looked anyway. That is what the view from in here actually is. Not just the light coming in, but a mind clear enough to understand what the light is telling us, even when the message is that there is no way out. There is one last question I cannot answer for you, and I would not try. If it is true that we are sealed in, that this galaxy is the farthest we, or anyone like us could ever truly go. What does that make it? A cage or a home? Some people hear all of this and feel the walls close in, feel trapped, feel the grief of every galaxy we can see and never touch. Others hear the same facts and feel something closer to peace, a sense that this one island of stars is enough, that a place you can never leave is just another word for the place you belong. I go back and forth on it, honestly. I do not know which response is wiser, but I think it is the real question left standing once the science is done, and it is yours to sit with, not mine to settle. Whether the fact that there is no way out is a tragedy, or simply the truth about where we live. I went into this thinking the hard part would be the engineering, the speed, the fuel. It was not. The hard part is that we are, in every sense that matters, sealed in. The galaxy holds us with a grip our fastest machine cannot begin to break. And even if we broke it, the space beyond is not a road to anywhere. It is a widening gulf, pulling almost every other galaxy away from us faster than light itself, faster than anything could ever chase. 94% of the galaxies we can see are already gone, in the only sense that counts. We can watch their light, we can never touch them, and that number climbs every year as more of the universe crosses the line and drifts beyond reach for good. I keep coming back to that faint smudge in Andromeda. Of all the trillions of galaxies out there, it is one of the mere handful we might, in some unimaginable future, ever reach, because it is bound to us by gravity in the small island we call the local group. Everything else, all of it, is already leaving. So could we escape the Milky Way? Not as we are, and perhaps not ever. And the deeper truth is quieter and worse. The galaxy is not really the wall. The wall is the whole universe pulling away, and it has been closing since long before we ever looked up. The light still reaches us from all the places we can never go. That is the view from in here. It is the only view there is. If you want to keep looking out from in here with me, a subscribe keeps us pointed at the dark.